really only have an hour. I really only have an hour because then I can catch a bus to Colonia to get a boat because my flight was cancelled. Okay, so never fly. I probably shouldn't say this on recording, but never fly Aviancia or Avianca. Okay.
So, 1 second. Let's say that we're taking questions in Spanish and English.
Sure.
So, if you want to ask a question, I guess they can interrupt you, no?
Absolutely. Please, I really want you to interrupt me. My goal is to get, in particular, the student. If one student asks me a question, I've succeeded. Okay. And the first bit is quite an easy topic to understand. There's really no statistics at all in it, so there's no complicated equations. And then I'll try and shift a little bit towards the latter half of the talk into multi-networks first and then multi-layer networks. Okay. If you don't understand me, please ask me to repeat myself. I will try and speak slower than usual, but I'm happy to take questions in Spanish and or English. Okay. So with that, I'm going to get going, given the time. So some of you might have heard about reproducibility or replicability, and so oftentimes these words are interchangeably used or confused, some might say. And so reproducibility has been looked at in medicine, psychology, neuroscience, a lot of the life sciences, quite in detail, I'd say, over the past 15 years. In statistics, we are definitely aware of it, but this is going to, this is a study on how well do we do in reproducibility in statistics. Now, just to tell you anecdotally, I find that if I email an academic statistician, they're more than happy to share their data and code. Okay, so anecdotally, that's usually what happens. I think we're quite a good community. Okay, but is that the right way to look at reproducibility in statistics? So I've listed here 4 questions that I want you to be thinking about during the presentation. How important is reproducibility in statistics and data science, given our economics, our economists here too? And you can think about, okay, economics, econometrics, all of these things. You're probably at a similar stage to us. There has been some papers, but not a lot of work. Who should be responsible for reproducibility? Okay, so should it be the author? Should it be the reviewer? That is Natalia. She's now working for JASA. Should it be the journal? Should it be the community? Who should that lie with? Okay, I'm sort of giving away my point here, but how can we improve reproducibility? So I will tell you that reproducibility is not great in statistics at the moment. So how can we improve it? And then what is the best strategy to guarantee reproducibility? Okay, so how do we incentivize people? Okay, I know that if somebody's not going to tell me to write my code or have my data and code available in a reproducible format, I'm not going to do all of that extra work. Okay, so what is this best strategy? How do we incentivize people? So throughout the talk, this is what I want you to be thinking about, and I will return to these questions at the end as well. Okay, so just so we're all on the same page, I don't expect anybody to know what the definition of reproducibility or replicability is at the moment, but I will get to that. So these are often cited as the cornerstones of reliable science, and studies that we can't reproduce or replicate, we should treat with caution. Right? We cannot guarantee that those results are true. Right? So over the past decade, as I've seen before in scientific journals such as Nature and Science, but also in economics, we've seen this word reproducible crop up more and more. And there's been multiple studies in psychology and medicine that shows that a lot of their studies are not reproduced. So what are the benefits of it? There has to be some benefits. If there's no benefits, we're not going to do it. Okay? So what are the benefits? So for authors, we think that if you produce reproducible research, this has a possibility of increasing the impact of your work. How? Well, citations. If I know that Ignacio has a method that I can easily use because he's an R-Paxton script, I can more easily compare my new method to Ignacio. So the possibility of impact through citations increases. Work efficiency. If you're in a lab or a team of people, you would hope that if you write your code in a reproducible format, this increases your work efficiency. It means that the next student can easily take the previous code and start working it straight away, rather than, and we've all been there, trying to read and work out other people's code. It's very difficult, right? So we think that teamwork, work efficiencies, all of these things are possible benefits for the authors. For readers, if we have seen that this has been reproduced, we're going to put more trust in it. Right? Our perceived quality of research, and then, as I talked about before, for readers too, easy adaptation, extension of this code and analysis. If we truly believe in that we're here to improve science, rather than having to go through or recreate Ignacio's code from scratch, we could just take Ignacio's code and build it. So it would be much more efficient for everybody if we did this. Is it more work? Of course it's more work. But we'll be starting from, greater and greater boundaries. So it means that we're going to be more and more efficient. Then for the public, so there's been a lot of, given the high propensity or a lot of emphasis on publish or perish, there's been more and more fraud or scandals related to data and code and replicability. So by the benefits for the public is prevents fraud and scandals related, and increasing the public's access to this research, which is a public good, given that it's probably being funded by public funds or taxes. So in 2016, Nature had a survey with the question, is there a reproducibility crisis? So as you can see here, 52% said yes, there's a significant crisis, and 38% said that there is a slight crisis. Right? So close to 90% says there's some type of crisis. So what is the difference between reproducibility and replicability? So I'm going to focus on reproducibility. Right? Replicability means that someone goes off and they collect a new data set. So new experiments, collection new data, apply the same methods, and try and get the same result. That's replicability. Reproducibility, which is hopefully a little bit easier to do, is I take your data and your code and I try and reproduce what you found in your paper. Okay. So should be easier to do, not as much cost involved, because I don't have to collect new data sets. Okay. So the focus of my talk, as I don't have a lot of money to replicate everybody's results, I'm going to focus on reproducibility and in particular computational reproducibility. Okay. Any questions so far? Am I speaking too fast or too slow? It's okay. It's okay. It's okay. Okay. So these replicability and reproducibility, I mean, they're seen as these cornerstones of good science, and they facilitate this ongoing self-correction, right, that we do. So once a result comes out, we want to push that result to the extreme. We want to see how robust that result is. Okay? So this is this sort of self-correcting nature of science. So ideally, we would do replicability. Okay, so get new data and try and reproduce or get the same results. But oftentimes that's difficult, as I said, costs, getting the same data, doing it in exactly the same lab. Quite difficult to do. So reproducibility is this sort of compromise. So taking your data that you collected and your code and trying to reproduce and see how robust it is. Okay. Okay. So you would think that reproducibility is quite easy to do. Right? That all I have to do is take your code and your data, and then I try and recreate them. Seems really easy. But there are, if I'm sure you're all have done this before, you've taken somebody's code and tried to understand their code, rerun their code, run into errors, version control, all of these multitude of problems. So it's not very easy at all. Right? So there's lots of problems. So a lack of detailed instruction for the analyses, highly customized workflows. Our computations are getting more and more complex nowadays. We have the computational power, so now we're creating more computationally intensive tools as well. And then large data sets. A lot of the data sets that we are now working on, we can't even store in our laptop, they have to be stored in some clouds. Right? So these are all the sort of problems in reproducible research. So in our experience, the most frequently occurring issues are access to the real data. Right? Availability of the final version of executable computation code, full details of the analysis workflow, and then a complete description of the computer environment. What version of R did you use? How many times have you seen this in people's code? Not many, right? So consequently, Donahoe, and this is a long time ago now, so remember this date, this is 2010, he said that there's a credibility crisis also in computational analysis. So this sort of idea that we're struggling with this computational reproducibility, Donahoe found in 2010. Right, so remember that date. That's going to be important. So as I've said before, anecdotally, I think as statisticians, I think we're pretty good at sharing code, but there's no quality control. I'm happy to send my code to somebody or my data to somebody. There's no quality control here. I can send you garbage, and you have to figure out how to work through it. And I'm not going to engage with you too much if I don't know you. You keep on coming back to me with more and more questions. So there's been some work on reproducibility in other computational fields. So I have a list of citations here. And in the past year, there's been quite significant, even in economics, in management science, and all of these more quantitative areas. There's been quite a bit of recent research. So these are some of the statistics literature of what's been going on. So back in, I think, back in 2007, so Gentleman and Lang, Victoria Stodden in 2017. There's been a biostatistics editorial, and then there's all nice software. So Knitter, R packages tracker that help you with your reproducible data and your code. Okay? So there's been, some recent work on how we can improve reproducibility in statistics. However, there's been no actual analysis of how well we're doing in statistics in terms of reproducibility. Okay? So to that end, a couple of years ago, a few students and I thought about, well, let's see how well we're doing in terms of reproducibility in statistics. So what we did was we took all the papers that study fMRI. Now, most of you I'll assume that none of you know what fMRI data is. So you might have heard of MRI, which looks at the structure of your brain. fMRI looks at the functioning of your brain. Okay. And the reason I chose fMRI is because I'm most familiar with this data type. Right? So I understand the nuances of this data. So we found all the papers that study fMRI in 7 prominent statistics journals. I hope you agree with me that these are 7 prominent statistics journals. From 2010 to 2021, we found 93 papers. Okay. And so the journals that we looked at were Annals of Applied Stat, Biometrics, Biostat, Journal of Computational Graphical Statistics, JASA, JRSSC, and Statistics Next. Okay. So we found that these were the journals that published papers in fMRI. Right? So before I get onto the statistics, I just want to show you what each of these journal requirements for their data and code are. Now, I'm not going to read out all of these, but I'm just going to state some of the words. I'm just going to emphasize some of these words. So AOAS, the requirement for the data says, strongly encourages authors to make the data available for others to analyze. In terms of codes, they say encourage. Biometrics encourages for data, and then they say strongly encourages for code, which it's so fascinating to me. See, even within the journal themselves, they use different terminology. Strongly encourage, 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 strongly encourage. Biostatistics, there is an opportunity for the data, and then for code, they're strongly encouraged. Again, mixed signaling to me. JCGS, authors are expected. That's pretty strong now. We're getting stronger. JASA, so JASA strongly encourages before 2021. And then after 2021, they have a editor for reproducibility, or associate editor for reproducibility. Okay, so post 2021, strongly encourage. After 2021, all papers, I think after a first round, must include code data and workflow to reproduce the work presented. JRSSC papers should, and then statistics in medicine expects and requires. Okay, so expects data, requires codes. Okay. So you can see that not all the journals have the same expectations in terms of, or requirements in terms of code data. And even within the journals, it's mixed messaging as well. Right? So try and remember if you can associate now these with later on. Okay. So students, here's your opportune moment to get famous. For those of you who haven't looked at the paper, and I'll assume most of you have not, how many of them could we reproduce? 3. Martine. Guess. 10. 8. What would you have thought before I introduced this topic? Before you walked into this room, what were you thinking? 50%. Right. So given my introduction, it's dropped from 50% to almost 0. Okay. Well, you're all pretty low. You're all too low. Okay, so we could reproduce 14, 15%. Okay. And just to make it clear, we were on the author's side here. We weren't trying to reduce this as much as possible. We wanted to make it really easy to pass this bar. Right? So we really wanted to help others. We tried to fix errors. We tried to do everything that we can so we could reproduce. So we were on their side. Okay, so we could do 14. And so here are the sort of overall table results. We also have journal-specific results, but I'm not going to, if you're interested in that, you can go to the paper. Okay? Again, what my goal here is, our original goal here was not to identify authors and journals. That was never our goal. You know, and that's why we don't name authors or anything. That's not our intention. I have papers in this. Don't ask me whether you could reproduce my work or not. Okay. So I have papers in this law. So what I want you to focus on is, you probably think 93 papers to reproduce, that seems like a lot of work. It's actually not that much work at all. Why? Well, if you look at the code provided and the code not provided, 46 out of 93 did not provide any code. So already we've gone from 93 papers to 47 without doing anything. Then we look at data provided and data not provided. We can see 51 data provided, data not provided 42. So we've basically gone from 93 papers to almost a quarter, just because somebody didn't provide the data or somebody didn't provide the code. So what a lot of people think is that it still is a good deal of work, because you need multiple people to test this, that it's not just one individual. But we reduced the sample size hugely, okay? Just because they're not providing code, not providing data. Yeah.
Data is more complicated with code is arbitrary.
That's going to be a really good point, okay? So fMRI, so remember this point, fMRI is an expensive data to collect, okay? So it's expensive, you have to put people in scanners, scanning time is expensive, okay? So a lot of people don't want to share this thing. And that's a really good point, and that's one of the limitations of this work. However, that's why I wrote in parentheses an update. I'm not just going to present this paper. We do have an update too. Right? So you can see here that the 14 comes from the real data and code work. Okay, so real data and code work. If you had simulated data, we didn't include you, right? Because we were focusing on the real data analysis. If you wanted to be generous, you could include the real data and the simulated data, and then you get 26 out of 93. Okay. In parentheses, you see 1 or 2. That means that people provided an R package. Right? Now, R packages are great, but in terms of reproducibility, and this is what Natalia and I were just discussing about, just because you have an R package, it doesn't mean that I can reproduce the work in the paper. For that, you need to give me a script of the step-by-step analysis that you did for the paper. I like R packages. I try as much as possible to create R packages, but you need to give me the script too in terms of reproducibility. Okay. Any questions on the table? Okay, how am I doing for time? Right. So here we have a plot that's kind of far away now. I'll summarize the plot by saying the good news is we're on an upward trend. So you would look at the far left plots, and if you're going to be an optimist, you would say that these are plots over time. So you can see that things are improving over time. So as we got closer and closer to 2021, which is the end of our study, the results are getting better. Right. So if you want to be an optimist, that things are looking up. Okay, so what do we recommend? What are the author recommendations? I'm going to talk about authors, journals, and remember those questions that I asked you to think about while I was giving this presentation. Think about that as well. So we think that the applications and case studies section of JASA, which Talia is involved with, does a good job. Right? For more insider information, talk to Natalia. So here, authors provide detailed computer materials, including step-by-step workflows to demonstrate reproducibility. However, what I've learned is that, I don't know if this is confidential, no, that they don't actually check for reproducibility. They just check that all the materials are there, or they check some parts of the reproducibility. Is that fair? I don't know. Yeah. Okay. One other thing about fMRI data is there's lots of pre-processing involved. Right? So the raw data is huge, and then people do a lot of different pre-processing steps, and they end up with, say, instead of having hundreds of thousands of time series, you end up with tens, 20s, hundreds of time series. Right? So there's lots of steps, and in general, what people do is they just give you the raw data. So let's say, here's the raw data, here's my computer code, over to you. But it is impossible, even with a description of the step-by-step workflow, it is impossible to go through that pre-processing and get the same data. Impossible. So while we admire people giving the code, you also need to give the templates, the brain mass, the parameter settings, all the steps involved in the pre-process. Give the raw data, give the pre-processing steps, and give the final product. That's the idea. If you're going to use our packages, provide manuals, clear paper scripts with lucid, straightforward instructions on the steps necessary to regenerate the results. Okay. So as I've talked about before, so for fMRI data, give us the raw data, all the steps, final data. As if you've ever worked with fMRI, this is an open problem in fMRI, is we have no optimal pre-processing steps. So almost everybody do these steps in different ways. And the obvious question then is, does that mean if I pre-process it in a different way to one lab, will I get different results downstream? Yes. So when these people are classifying, when you read in the newspapers classification of Alzheimer's disease or schizophrenia or ADHD, you should be thinking, well, if I change the pre-processing steps, I might get slightly different results to what the article is publishing. So scary in one way, but an opportunity in another way. Okay? So I'm just going to skip the ADHD because that's more specific to people in neurostatistics. Journal recommendations. From my perspective, I think the police should be the journal. So in summary, that's where I think it should come into play. If they, instead of saying expect or encourage, if they say everything's going to be checked for reproducibility, then that's what we're going to do. Because we want to get published. I'm not expecting the journals to do all of that work, because that's a huge amount of work. But there are other strategies in that. Right? So I think if the journals state that everything is going to be checked in some way or another, then we're going to write code and have data in a reproducible form. And you can disagree with me. That's what I want you to do. I'm loving to disagree with you. Right? So what biostatistics do is kind of cool. So they wrote an article in 2008, which is 16 years ago, about reproducibility, and here we are 16 years later. Okay. And so they have something called a kite mark. So it's D if the data are freely available, C if the author's code is freely available, and R if both data and code are available. And so out of the 13 papers that we had in our study, 3 were C marked, 1 was D marked, and 2 were R marked. Okay. So even within a journal, it's not perfect. Even though in 2008, so 2 years before our study, they were talking about this. Okay. So this problem is not solved. Okay, so we want to move away from expect, encourage, etc. We want you have to, for both, for everyone. Assign, just like Jazz, an associator for reproducibility. And then what I said before, I don't think the journals have enough manpower, or person power, I should say, to do all of this work. So there's different strategies. So Natalia just told me about there's a competition on reproducibility. So basically get students to do the work. Okay. By creating a sort of, bring them together in a seminar or a conference, get them to reproduce lots of papers in that one day, sort of reproduce hack or something like that. Or what I was thinking was, I had to do a couple of semesters of consulting when I was a PhD student. Why don't we get, top statistics programs, biostat and statistics programs that have outreach so that journals can send papers to different programs and ask them over a semester to try and reproduce that work. And maybe that, then it's like funding. Well, perhaps some sort of national funding can organize this. I don't have all the answers here, but these are just some suggestions. And we should, Natalia told me there is a reward in this reproducibility pack. I think in statistics, we are terrible at giving out rewards for authors and referees. I look at my business school colleagues, and you see in their certain CVs, there's awards for everything. They get awards and conferences and presentations and everything. I think statistics, we should be doing something similar. Right? Incentivize people to do this. If you say there's an award for something, people are going to try and win that award. Right? All right. So we conclude that overall, we're not doing great, I would say. There's definitely room to improve. One of the limitations, as we discussed, is this could be proprietary data. So how well does this generalize across different areas of application in statistics? And the other limitation is we did not contact the authors. At no point did we get in touch with the authors. We just looked at the journal's website and see what we could do from there. Because again, if we contact the authors, there's no quality control. We don't think it should be at the author level, it has to be at the journal level. So we think that fMRI lies in this, it's not very open. There are some open data sets. And we compared it to something like stock prices and returns that are available online. Okay. Okay, in terms of time, I'm just going to skip this. So the paper's available since last year. So if you're interested, you can take a look. So I return to these questions. How important is reproducibility for the statistics community? Who should be responsible? How could it be improved? And what is the best strategy? Comments? You disagree with me on anything? Do you agree with me?
I think just push with top down, or expect something more bottom up, then you have to improve incentives.
Yeah.
Because there aren't really incentives for research. Like you said, maybe you improve the citations.
Yeah, yeah.
But people still cite based on the results.
Correct.
Right?
Yeah.
So you don't improve really the incentives for authors, at least when the very hard. Right? Only with the journals enforcing it from the top.
So you think it should be bottom up, or?
It should be bottom up.
Okay.
I think it's not, the journals can help.
Yeah.
But it really needs to be a clear
A culture
of the author.
Okay.
And that's not something coming from the community, how the community values papers that are reproducible over papers that are not.
Yeah.
And maybe this is a step, because if you have the journals enforcing it, then it becomes clear that it's desirable.
Yeah.
Slow process. But
Yeah.
I think the real change comes when everybody understands that they have to do this.
Well, that goes then to my first question: how important? I mean, clearly, does that mean it's not important at the moment?
No, it is. It is.
Okay.
It's just difficult.
But do you think it's important to everybody?
Yeah. Well, I think it's important for everybody. Sometimes it's hard. For example, I recently published something that's based on property data. So we published the results from a certain stage, but there's the beginning of the raw data we cannot provide.
Yeah.
So this will never be reproducible because it's not. It's even if we wanted to, but it's some data that we paid and I cannot make it public.
Sure. But there's ways around that.
In those cases, we like when you have data that are not you cannot share the Charla, we suggest that you can simulate some synthetic data to reproduce the result as close as you can in terms of, and that is yes, I think one of the key points is if top journals are making the effort to make the reproducibility, people will, that is an incentive, because if you don't have reproducibility in JASA, you will not get the paper published. That is something
that is strong
think
incentive.
yes. And also there is another thing that I maybe is if we make the citation of the if you have another package and you make the citation for that, obviously maybe that is not like the reproducibility material for the paper, but it's part of the material that you have, that will be another important piece.
Right. Right.
I am kind of biased about.
Yeah,
Thank you.
It obviously helps. I mean, I'm just trying to.
Yeah, exactly, yeah. Any other comments? Yes, Marco.
First of all, thank you for pointing out this topic. My point is that in some sense, reproducibility can be considered as a sort of baseline. But you know, if we are considering the life cycle data, then, as you mentioned before, for instance, we may reprocess data in different ways. Maybe none of them is wrong, none of them is correct. And so from this perspective, some authors advocates the robustness, which means you may prefer because part of your analysis.
Yeah.
So the point is that I consider to be relevant reproducibility under a series of conditions,
Correct.
of assumptions
Yeah.
that must be delivered to the readers one.
Yeah.
But then, of course, if you consider real problem data necessarily, you may, I mean, your main concern is to solve a research problem. The main question that we have in front of you. And so there are so many variants sometimes that right now, I mean, thinking in your so nice presentation, maybe some sort of reproducibility is sort of baseline.
Yeah.
And in fact, many packages, they say, okay, you put this data, you apply scope, these are the results. We do this and we obtain the same results.
Yeah.
Then in real problem with real data, as I and other, yes, you are exposed to so many decisions, right? And then, yes, it is an open question for you.
Yeah, I mean, what you're saying is like reproducibility, and that there's a different type of reproducibility, which is robust reproducibility, that if you tweak things, we still get a sequence, absolutely. And there's all different definitions of reproducibility now. People have got various, so this is like a baseline reproducibility. What you're suggesting are papers now defining different types of reproducibility and replicability and various things. Yeah, I can send you that paper if you're interested. Okay, in the interest of time, I'm going to skip on. So, of course, given the age of ChatGPT, when ChatGPT came out around November 20, around this time 2 years ago. 2 years ago. So I was worried, oh God, could ChatGPT have done this for me without hiring numerous students to do this hours and hours of work? So could ChatGPT have performed this study? So I sent it to ChatGPT and I said, what is the reproducible rate of paper study and fMRI published in these following journals? So luckily for us, we can't do it. Not yet. It might come in time.
The new version is
Exactly, yeah. So not yet. So the update then is, my slides are a little bit off here. So the update is, well, I also have an interest in finance and economics as well, right? So in tune with this question is, well, fMRI data, no, it's proprietary, it's expensive, yada, yada, yada. What if we looked at economics and finance data? So here, recently, so this paper is just under review. So we attempt to reproduce 241 papers studying economics or finance published in the statistics journals. Now, I'm not talking about Journal of Finance, American Economic Review, all of those. That's over to you economists. I'm not, that's not my word. So we've 8 journals. We've more than doubled our number of articles. My team is now bigger. So I would say prominent statistics journals who publish in this area. How many of those 241 could be reproduced? Worse?
Yeah.
Okay, so worse. A bit bigger? Bigger than before.
18.
Well, it's not gonna be exactly the same. So it is around the same as before. So we have, I mean, we separate them a little bit here. We do work or partially work. You know, we look at more detailed results in terms of figures. We look at figures reproducibility and also the results tables reproducibility and the results of the code. So if we're going to be generous, we would say 37 over 241. If we're not going to be generous, going to be trying to create some screaming, it would be 17 over 241. Right. So don't have a that's the results, and we just look at the results slightly differently than. So in terms of application area, there's still an issue. Right? It's not just unique to fMRI data, and also this is much more recent. This is just about 2 years, 2021 to 2023. Okay, so I don't have much time. Okay, and so I'm going to skip out reproducibility, and I'm going to talk a little bit about networks. Right? Well, before I leave reproducibility, is there any more questions there? Okay, I'm going to speak a little bit about fMRI. Given that scientific place time. How many people have heard of fMRI data? One. Fantastic. Okay, fMRI data is just time series. Many people have heard of time series. I assume, yeah, given where we are. Okay, so what happens in fMRI is we, in summary, pre-process the data. We discussed that already. We highlight areas of the brain. So here we've got, is it 8 regions, and then each region of the brain has a time series as the subject performs a set of tasks. So that set of tasks could be watching a movie, resting, clicking your fingers, getting burnt, solving chess moves, solving mathematical puzzles, anything like that. Right? Various different types. So each has a time series. And then what we can do is we're interested in the brain as a system. So we're interested in the dependence between these areas of the brain or these time series. So it's going to be very easy. You can estimate a correlation matrix, a precision matrix, or if you want each region of the brain to be represented by a node, you can estimate a graphical model to represent the dependence between these areas of the brain. Again, this time series, and we're interested in dependence. Well, what's the problem with that? There's many problems, but what's one problem? So if you're in a scanner for 10 minutes, what do you think is happening between those regions of the brain? Or putting it another way, if we estimate a precision matrix or a graph for those time series, what are we assuming? They are related, yeah. So this is one graph over 300 times. And one graph is a good representation of that whole experiment. If I sat you with a scanner, do you think you would think about the same thing exactly for 10 minutes? The connectivity in your brain would be constant for all those 10 minutes. Who think that they could do that? Stand up, butt up. Or you could fall asleep. That's also quite common. People go in there, they fall asleep. So no, we expect that the brain is dynamic. We're constantly thinking about something else. You're probably thinking about dinner or lunch or coffee already. So by representing this dynamic process by one dependence or graph measure, it's kind of the simplified version. Right? So what people have done is they've moved on to what's called dynamic functional. So how do we estimate the change in connectivity between these? Similar to financial time series, how is the dependence between my financial time series changing over time? Right, we call them structural changes. So in neuroscience or neuroimaging for fMRI data, the way people estimated this was using what's called a moving window. So they specify a number of time points, they estimate a precision or correlation matrix, they shift the window, do the same thing, and keep on shifting it until you get to the end of your time. Nice, computationally feasible way to do this. Okay? Problems are, what's that size of that window? Too small, unstable estimates. Too big, you're going to miss some of these changes. Okay? So we approached it from a different perspective. We approached it from a more data-driven change point perspective. Well, why don't we let the data tells us how big those windows are? Okay? I'm not going to go into details of all of those things. So I've done quite a bit of work on this, and I packages, papers, good bit of work over a decade. But we've lost. The change point people have lost. Our papers are cited in hundreds if we're lucky. The moving windows papers, thousands. So we've definitely lost the battle on this. In terms of I'm talking about the neuroimaging community. What do they use? They're not using change points. That's way too complicated. Okay, even though we create packages, we do all this work.
That is cited less, or is it that it's really not as good as the other?
Oh, well, of course. We have lost the battle. Well, can we win the war? I'm not giving in yet. So perhaps it is. Now we thought, well, maybe this Windows stuff really is better than all our complicated change point models. So that was the motivation. So the motivation was, well, is change points better than window? Or is this dynamic even better than static? Because people use that one graph for the whole time series. People use that as inputs into classification models. We don't know which is better. So that was this one. So first question is, should we use any dynamics versus static? And second question is, should we use window versus change? So the way we're going to approach it is, well, how do you define better? You know, we can say, well, we can design experiments and we find changes, they find windows. How do you compare these two things? Right? So we took it from a classification point. Right? How well can we, as inputs into a classification model where we know have a disease status, say Alzheimer's and not Alzheimer's, which is a better input in a classification model, static, window, or change points. Right? Well, you know what the answer is. I wouldn't be presenting it to you if you didn't know what the answer is. So we go through, in the interest of time, we go through all of these steps, and we find, lo and behold, that the change points outperform all the dynamic windows. No matter, we give it everything. We allow all different types of windows, sizes, overlapping, non-overlapping. We find that change points win. Not significantly better than the best window, but better overall. And in terms of interpretability, much more easier to interpret. Right? Because you only have a certain number of windows. Well, with the window, you've got lots of different windows. You've got hundreds of windows. So in terms of interpretability, also better as well. Here we do a window base, so you can see that the results, here's the different scores of different step sizes and whether overlapping or not. You can see there's this huge variation in the performance of the window for different step sizes and whether it overlaps or not. Okay, so the last thing, I'll just give me 1 minute. I'm a bit over time. 1 minute. Last thing I want to talk about is, thank you for your attention, multilayer networks. Many people have heard of multilayer networks. One. Okay, right. This is all new stuff. Okay. So multilayer networks is, at the moment in statistics, is a really growing. Okay. So this is sort of a new problem. So you have a network. You just are trying to estimate the edges in that network. Multi-layer networks is a network of networks. Right? And so you have networks one on top of each other, and the difficulty is estimating or even computing the interlayer connections. So the connections between each layer of the networks. Okay? Real difficult problem. So some examples, just so you get a flavor of this idea, is transportation networks. Okay? So think about a transportation in a city. So this is of Paris. Various different types of transportation. Right? But how interconnected are those forms of transportation? If I'm going to move from bus to rail to subway, can I do that quite easily? Either by direct or by walk. So the left-hand side, and this is a lot of work, these plots. The left-hand side shows the connectivity with direct between each form of transportation. And the right-hand side shows us when we want to walk between, the interconnectivity when we allow for walking. So you can see here that there's a huge difference in terms of the connectivity. So that's just one project. And then the second project is, I'm going to stop here, I'm not going to go into the details of all the different stats, is estimating these interlayer networks. So in brain imaging, we have different modalities. One's like EEG, which is very fast temporal resolution, and we've got fMRI. But how can we combine these two data sets? How can we estimate the interlayer networks between these two data sets? So this method that we have, which uses like sort of latent variables and various different techniques, sparsity, this is a method that estimates those interlayer connections. So with that, I'll stop here, open for questions. Thank you for your time. Any of the above. You can ask me anything or anything else. Yep.
So I would like to know the view. I think one issue with this is when the technology is changed. I think it's we have indicators at the moment that rely on computational solution. I think computational solution might be. It will be available next year, maybe it will be available 2 years.
Yeah.
Later, but I don't know, maybe 10 years, we are no longer able to bond them more because software part of whatever is no longer available.
Yeah.
No, it's something that people care about.
I think that comes down to, well, how much importance we put on this. You know, are people going to go back 10 years later and rewrite that code in a new software because the old one's not available? At the moment, that's up to the individual. They want people to still use it. Yeah, but I guess so. You know, I create these things in R. These things in R. Neural engines are not going to really touch R. You know, if I'm going to be honest, most of them won't go near R. They've got, you know, their clicks. You know, they upload their data, they click some buttons. This pre-processes and analyzes the data. So in terms of reproducibility of that, that's really hard. You know, it's like if you ask ChatGPT to give you some instructions for Excel. Have you ever given ChatGPT Excel? It's a nightmare. Really, really terrible. But in terms of writing our code, very good. So to me, you know, it'll depend. If it's worth it, people will do it. But I can't imagine statisticians going back to work that was 10 years old and rewriting it in a different software. But I'm not saying it doesn't happen.
But I think maybe right now we have the software to, like, if you are right now and you are using a version of R, some version of package, you can use Docker to make an encapsulate of the things that you are running, and in 10 years you can run everything again. That is something to protect the reproducibility right now. We have like some tools that protect the reproducibility, even when like in 10 years, you will be able to have, if R doesn't
Yeah.
disappear.
Yeah.
That is something we are assuming that
Yes.
will not disappear. You can download the R version and all the versions that you have for each, and in Docker you have that too. But maybe it's not something that you can generalize for all the.
No, I mean, I understand that may be solution to a issue, right? I want to think it like, as I was saying, I mean, if that question is important, I think the other way, as an you create something, you have an example, and you have to put a lot of effort to make it reproducible. But at the same time, you know that the technology will evolve and make the technology that I'm putting a lot of effort to make it reproducible, it won't longer be used. in the future. So,
But I think like, for example, if you. No, but if you have a lot of citation of your package, for example, your Fabi search, if someone will use the package and that people say, okay, I have problem to run, and everyone like, and you will like have the incentive to improve the code to make that works because people is using and making preference. That is your incentive. At the end, you will have more citation and people using your work. That is.
So papers and articles should be more of a, something that is dynamic, not you do it once.
Oh, yeah. It should be, but again, what is the incentive to go by 10 years and do it? Because you're working, you know, are we being incentivized to do that? No.
So maybe the question is about like changing the pace of application, the general incentives in academia.
Oh, well, yeah. If we could all slow down, I think we would do more reproducibility. Yeah.
Okay.
Thank you.
Thank you.
Oh, yeah.
Deep learning, all that you have some opinions to deep learning on that series.
Oh, really?
Once you get 80% of that.
Yeah, absolutely. Yeah, I'll be back for sure. Cool. Yeah.
Hey, you have to run.
I know. Yeah. Let me order the.
The
Or,
Uber,
yeah.
Yes, nice talk.
Thank you.
People like here.
Oh, no,
Even
yeah,
when
yeah.
it's December and you
I
don't
know.
like them, for us, it's a little.
Yes, okay. Yeah, I'll be in touch. Yeah. Thank you so much. Yeah. Thank you. Marco,
Thank you so much.
Yeah.
For inspiring the whole. Thank you. I have to read your paper.
Okay.
I can compare it so between the slide issue
Okay.
and say the fix the week.
Yes.